Greetings. You may or may not have been confused by the idea that sines, cosines and tangents, sine, cosine and tangent, all relate to right angled triangles, and yet they're all curves. But there aren't any curves in a right angled triangle that I can see, and this is a very badly drawn one. So I guess we need to look at why we have sines, cosines and tangents related to right angled triangles. Well, the right angled triangle itself in this context comes from the circle. I'll draw a rough circle if you don't mind. And what I want to do is to assume this is roughly the center. And there we have a radius, and I want to rotate that radius in an anti-clockwise direction. It doesn't matter which direction I rotate it, but this is the convention. But if I move this radius in a anti-clockwise or counterclockwise direction, I'll move it, let's say, to here, and then to here, and then perfectly upwards. Which, let's call this 90 degrees, I think, and let's call this, say, 60 degrees, and let's call this 30 degrees. Now, what's happening here is I'm rotating a radius anti-clockwise, and the radius happens to be the hypotenuse, that is the long side of a right angled triangle. And what I need to do now is to try and establish that the right angled triangle actually comes from a circle, and therefore the sine, cosine and tangent curves can be related directly to right angled triangles, which is not always taught. I could do that. And what's happening here is this is a right angle, this is a right angle. And what's happening here is that as the opposite, this is the angle we're talking about, theta, as the opposite side to the angle increases in length, so the adjacent side decreases in length. Now we come to a strange phenomenon, because the sine of 90 is 1. But I'm sure you've been told that SOHCAHTOA tells us that the sine of an angle is the opposite divided by the hypotenuse. Now it's very, very odd that if the answer to this if the answer to this fraction is 1, then the opposite, the length of the hypotenuse and the length of the opposite must be the same. Now, I defy anybody to draw a triangle that has the opposite and hypotenuse the same length. And that is why I'm trying to emphasize that the sine, the cosine and tangent, which are all curves, must come back to the circle. They can't go back simply to what is referred to as trigonometry. It is a shortcut to understanding exactly what we're doing here. If I can draw another circle here, I can actually, not very good circle, do the sine wave 1, 2, 3, 4, and so on. And what we can do is translate this graph from this rotation of the hypotenuse, which is the radius of a circle, in fact, and we start here, and you can plot the graph of these rotating radiuses, and we will plot a sine wave. The sine wave, ladies and gentlemen, comes from the circle, not from the right angled triangle. It is back to front. Thank you.